Alright, so this is 6.7, which is kind of about financial models that use exponential and logarithmic equations. The first application we're going to be looking at is simple interest. The simple interest formula, you've seen it before. We talked about it back in our first unit. But it's I equals PRT, where I is the interest that you got, P is your principal, your initial investment, R is your interest rate expressed as a decimal, and T is your time in years. Now, here's the thing. Most accounts, when they do interest, they don't compound it only annually. Sometimes they compound it quarterly, which means it's done 4 times per year, or maybe semi-annually, so it's done twice a year, or monthly, so it's done 12 times a year, or maybe even daily, so it's done 365 times a year. So depending on how frequently they compound the interest, how frequently they calculate the interest, it can change the amount that you earn. So when we do compound interest, we're basically saying that, hey, we earn this interest in a certain amount of time, and then we add that back into our amount, and then we calculate the next interest. And then we add that interest back into the amount, and we calculate the next one. And then we add it back in, calculate the next one, add it back in, and it just keeps building upon itself, which is why it's called compounding. Okay. Now, there is a formula for compound interest that we're going to learn in just a minute, but I want to kind of show you how it works if you use just the simple interest formula to calculate. So example 1 here says that a credit union pays interest of 2% per annum, per year basically, compounded quarterly on a certain savings plan. And it says if $1,000 is deposited in such a plan and the interest is left to accumulate, how much, and this is supposed to say is, how much is in the account after one, that should say year instead of years. Typos. Okay. So, how many quarters are in a year? Well, there's actually 4, so we're going to say, hey, here's quarter 1. So I'll just do it like this. So there's quarter 1, quarter 2, quarter 3, and we'll go over here and say quarter 4. Okay. So what we need to do is figure out how much interest we earn, okay, in each of these quarters and add it into our amount. So our interest is going to be our principal. In this case, we started with 1,000, times our interest rate, which was 2%, 0.02, times our time. Now, this time we're doing it quarterly, so we're only doing 1/4 of a year. So this is 1/4. And then we'll go to our calculator and we'll figure out what that is. So 1,000 times 0.02 times 1/4, and we get 5. Okay. So now, the amount that we have to take the 1,000 we start with and add this $5 that we've earned in interest. So now we have $1,005. Okay. Quarter 2, calculating the interest. The amount we're starting with now is $1,005. We're still using an interest rate of 2%. And then for our time, it's still another quarter of a year, so it's still another 1/4 of a year. And so then we'll go to our calculator and figure out what that is. So 1,005 times 0.02 times 1/4, and that ends up being 5. Well, since this is money, it only carries to the 3rd decimal, so this would be, second decimal. So this would be 5.03. So that's how much interest we earned in the 2nd quarter. Add that back into our amount. So now the amount we have, we started with 1,005. We added another $5.03. So now we're up to $1,010.03. Okay. So now I want to calculate the interest again. So we're going to use this, but we're actually going to use the unrounded decimal, okay? Because banks usually do keep track of these decimals. So we'll have $1,010.025. That's what the decimal was, 0.25. Oops. And then we have the same interest rate, 0.02. And then we are still doing another quarter of a year, so that's 1/4. And so then we can find our interest by doing the multiplication. So, oops, $1,010 and 0.025 times 0.02 times 1/4. And so there we go. So $5.05. So now the amount in our account, if we add this in, it's going to be $1,015, and 5 and 3 makes 8 cents. So here's where we're at now. Alright, we got one more quarter left to complete a whole year. So again, we're going to calculate the interest again. So we have 10, 15 point, and this is all of this decimal, 0.50, 125. And then we're going to multiply that by the 0.02, our interest rate. And we'll multiply that by another quarter, 1/4. So 10, 15.050125. And we're going to multiply that by 0.02. And multiply that by 1/4. And so that gives us 5.08. And so we're going to add that into the amount we had. Ooh, actually, I just realized something. I wrote 0.5. It actually should be 0.8, right? Which means this needs to be changed a little bit. So I'm going to pull up my previous entry. I'm going to change that to 0.8. Which is not going to change it a whole lot. It's still $5.08. I just wanted to verify. Alright, so we had 10, 15, and 8 cents. We need to add $5.08 to it. So now we have $1,020.16. Okay. So you can kind of see it's a slow and laborious process to make this work. Okay. It's kind of unpleasant. You have to sit here and calculate the interest, add it in, calculate the interest, add it in, calculate the interest, add it in, calculate the interest, add it in. And we only had to do it 4 times. Imagine if it was monthly, you would have to do it 12 times. Or imagine if it was daily, you would have to do it 365 times. And that's just crazy. So instead of doing it like this, mathematicians actually developed a formula for this compound interest. So that's what you can see right here. For compound interest, instead of doing it with the simple interest formula and just adding it back in, we use one of these formulas. Okay. If we are compounding n times per year, so like quarterly would be 4 times per year, monthly would be 12 times per year, etc., etc. Okay. And this is our formula. A of t equals p times 1 plus r over n raised to the nt power. In this, a here, this a of t, represents your amount after a time. That's how much is in your account after the time has elapsed. P is your principal, your initial investment. R is your interest rate as a decimal. The n that's down here and the n that's up here in the exponent, both of those are the number of times per year you're compounding. So again, quarterly would be 4, monthly would be 12, daily would be 365, semi-annually would be 2, I mean, just all that. And then t up here in the exponent, t is time in years. Now, there are occasions where you have what is called continuous compounding, meaning that it is always compounding. It is never not compounding. So like every fraction of a second it is compounding. It is always building upon itself. This formula is a little bit easier. A of t equals PE raised to the RT. Again, A of t is your amount after a certain period of time. P is your principal, your initial investment. E is the natural base number that we learned about in 6.3 and talked about again in 6.4 and 6.5. Okay, E is that special number. R is your interest rate as a decimal. T is time in years. If you want a more in-depth look at these formulas and where they come from, you can look in the book. There are some references for it there. Okay. So example 2 here asks us to, it says you decide to invest $8,000 for 6 years, and you have a choice between 2 different accounts. I'm just going to kind of divide my workspace here in 2. The first account pays 7% compounded per year monthly, and the second pays 6.85% per year compounded continuously. It asks which is the better investment. Well, A equals, the amount we're investing is $8,000. For this first one, it's compounded monthly, so we're going to use the first formula, this one right here. So we have 1 plus the interest rate, which is 0.07, divided by, it's compounded monthly, so that's 12 times per year. That number down here is also up here in the exponent, and it gets multiplied by the amount of time, which we decided to invest for 6 years, so it's getting multiplied by 6. And then at that point, you just go to your calculator. So I have 8,000, parentheses, 1 plus 0.07 divided by 12, close my parentheses, raised to the parentheses 12 times 6. Close parentheses. I want parentheses for the power, so that way the 12 times 6 happens inside the power. So make sure I put parentheses around it. So there's what we end up with. We have $12,160. What was that, 84 cents? Yeah, 84 cents. So this is how much we would make on that first account, how much we'd end up with. Right, the second account is the one that pays 6.85% compounded continuously. So this time we're going to use the continuous interest formula, which is this one, A equals PE raised to the RT. So my principal is still 8,000, and I have E. My R is my interest rate. In this case, it's 0.0685, and that gets multiplied by my time, which is 6. And then we go to our calculator. So we have 8,000. We're going to do second ln to put an E in there. And then inside that power, we will have 0.0685. And we're multiplying that by 6 years. And so there we go. We get $12,066. And 60 cents. Okay. So which one is the better option? Which one's the better investment? Well, this one will get you a little bit more money. So the 7% compounded monthly. It's the better deal. And that happens sometimes. Sometimes compounding monthly is better than compounding continuously. A lot of it depends on the interest rates and the amount of time that you're willing to leave it to compound. So that's how we do those. Now, these formulas that we have been reworked to help us find other things and to help us evaluate better. And one of the ways we do this is with what's called the effective interest rate. Okay. The effective interest rate is a way to convert an interest rate that's compounded monthly or continuously or daily into an interest rate if it was just compounded annually. So that way everything can be compared equally, and you can kind of see, you know, about which one would be the best if they were all on the same footing. Now, how do we calculate this effective interest rate? Well, if you're compounding n times per year, the effective interest rate, R sub e, is equal to 1 plus r over n raised to the nth power minus 1. If you're compounding continuously, then your effective interest rate is R sub e equals e raised to the r minus 1. So let's see how we can put this into action. Here in example 3, it says, suppose you want to buy a 5-year certificate of deposit. You visit 3 different banks to determine their CD rates, their certificate of deposit rates. American Express offers you 2.15% compounded monthly. First Internet Bank offers you 2.20% compounded quarterly. And Discover offers you 2.12% compounded daily. It asks us to determine which bank is offering the best deal. Now, some of you might say, oh, it's 2.20% because that's the highest percentage. Some of you might be like, oh, no, it's got to be the Discover one because it's daily and that compounds it the most frequently. Well, this is why we need this effective interest rate. We need to be able to compare them on the same footing so that way we can make all things equal and say, hey, this is the best one. So let's find the effective rate for each of these. We're going to start with American Express. Okay. For American Express, they are 2.15% compounded monthly. So we're going to use this formula. R sub e equals 1 plus, the interest rate is 0.0215 over n, because this is monthly, that would be 12. And then that gets raised to the 12th power because that's n up there as well. And then minus 1. And so I'll go to my calculator and figure out what that is. So 1 plus 0.0215 divided by 12, raise that to the 12th power, minus 1. So I get 0.0217, or 2.17%. So that's what it would look like if it was just a flat annual percentage. All right, let me switch colors here. Our next one is the First Internet Bank, and they are 2.20% compounded quarterly. So First Internet Bank, which is FIB, their effective interest rate is going to be 1 plus 0.0220 over, since it's quarterly, it's 4 times per year, raised to the 4th power, minus 1. Again, we go to our calculator. So 1 plus 0.0220 divided by 4, raised to the 4th, minus 1. So we get 0.0222 if I round it to the 4th decimal, which would be the same thing as 2.22%. And then our last one is Discover, which is 2.12% compounded daily. So for Discover, the effective rate, we have 1 plus, their rate was 0.0212, divided by, for daily, that means it's 365, and that means it's getting raised to the 365 power, minus 1. And we go to our calculator. 1 plus 0.0212 divided by 365. Close that parentheses, raise it to the 365 power, minus 1. There we go, 0.0214, or 2.14%. So, we've now made them all equal. They're all now compounding annually. And so, now that they're all equal, we can see which one's the best deal. The best deal is the FIB, the First Internet Bank. the First Internet Bank is the best deal. The worst deal is Discover. Even though it's compounding daily, it has this lower percentage, and it gets divided by that 365, and it's just not going to be a very good deal. You get 2.14%, not good. Okay, so the fib ended up being the best. But this is the way we can evaluate. We just convert them so that they're all compounding at the same rate, and then that allows us to see which interest rate is the best. Another thing we can do is we can kind of work backwards, okay? So if we know how much money we want to end up with, we want to know if we know how much we want in the future, we can actually solve backwards to get the present day value, the present amount that we would need to invest in order to end up with that future amount. And so in order to do that, your principal that you need to invest is going to be equal to A, the amount you want to end up with, times 1 plus R over N raised to the negative NT power. Or if you're doing it continuously, the principal is going to equal the amount you want times E raised to the negative RT, the negative interest rate times time. So let's work some problems with that. Example 4 says a zero coupon, which is a non-interest-bearing bond, can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want a return of 8% compounded monthly and 7% compounded continuously? So we have two different problems. Okay. Part A here, we want to figure out how much should we pay, how much should our present value be if we want to get 8% compounded monthly. So our present value P equals, the amount we're going to get at the end is 1,000 times 1 plus the interest rate we want is 8%, and we want it monthly, so that's 12 times per year. And that gets raised to the negative n again, which in n is 12, so that's negative 12 times, and t is how long we have to wait. Well, we have to wait 10 years, so that's times 10. And we'll just go to our calculator. So 1,000 parentheses 1 plus 0.08 divided by 12, and raise that to a parentheses negative 12 times 10 power. And so we go 450.52. Okay. So if we pay $452.52 for this bond right now, then when we get it in 10 years and get that $1,000 out of it, it would be like we had earned 8% compounded monthly interest on it. Alright, for B, we want to do 7% compounded continuously. So we're going to use this formula over here. So our present value P equals the amount we're going to get, which is $1,000, E to the negative. Our interest rate in this case is 7%, so it's 0.07 times our T. Well, our T that we have to wait for is, 10 years? So we have to put 10 in there. So we go to our calculator, 1,000 E, second ln, negative 0.07 times our time, which is 10. And so we get 496.59. So if we paid $496.59 for this bond right now, would we get that $1,000 in 10 years? That's like we would, or it's the same as if we were earning 5 or 7% compounded continuously on it. let's look at a little more complicated problem, not a whole lot more complicated. So example 5 asks, what annual rate of interest, compounded annually, is needed in order to double an investment in 5 years? So, again, this is our formula. A equals P times 1 plus R over N raised to the NT. Okay. I'm going to start by filling in this side. Okay. They didn't tell us a principal. Okay. So I'm going to have to leave that as P. 1 plus. They also didn't tell me an interest rate, so I'm going to have to leave that as R. Divided by. N is how many times it's compounded. Well, they told us it's compounded annually, which means 1 time per year. And that means the N up here is also a 1. And then T, they told us we want this to happen in 5 years, so that T is getting multiplied. T is 5, so it's 1 times 5. Now, over here, our amount, they told us we want to double our investment, which means if we're taking P and we're doubling it, we get 2P. So I'm going to clean this up a little bit. This is 2P equals P times, here R divided by 1 is just R, so this is 1 plus R. And then up here, 1 times 5 is just 5. This is our new equation. 2P equals P times 1 plus R to the 5th power. Now, the next thing we're going to do is we're going to divide both sides by P. What happens is the P's will cancel out. So this P will cancel out that P, this one will cancel out that one. And so we end up with 2 equals 1 plus R to the 5th power. Okay. Now, how do we get rid of a 5th power? Well, you do a 5th root. So this is the 5th root of 2 equals 1 plus R. And then you can move the 1 over, so this is the 5th root of 2 minus 1 equals R. Now, to do your 5th root in your calculator, the easiest way to do it is to turn it into a fraction exponent. So this is 2 raised to the 1/5 power to do a 5th root. And then we're going to subtract 1. So there we go, 0.1487, I guess. Which, if we turn it back into a percentage, that's 14.87%. So that would be our rate that we would need to get for our interest if we wanted to our amount to double after 5 years, if it was just compounded annually 1 time per year. And you can kind of see that it works. Because if you take that interest rate and plug it kind of back in up here, 1 plus that answer is this. And then when you raise that to the 5th power, it becomes 2. And that 2 multiplies by your principal, which will double it. So actually check it and see that it does work, in fact. This is our very last one. Example 6 here asks us, how long will it take for an investment to double in value if it earns 5% compounded continuously? And how long will it take to triple at this rate? So, 2 different things to do. In part A, we want to double at 5% compounded continuously. So for continuous, this is our formula. A equals PE to the RT. I don't know my principal, so I'm going to have to leave that as P. E is just our special math number, so we leave that there. Our R is our interest rate, which is 5%, so it's 0.05. Our T, we don't know because they're asking us how long, so we have to leave that in there. And then our amount, well, we want to double our investment, so we want to double this P. So that means we want to have 2P. Next thing we're going to do is we'll divide both sides by p, which allows those p's to cancel out. So this one cancels there, that one cancels there. And so we end up with 2 equals e to the 0.05t. Now this is actually an exponential equation. Remember, we can solve exponential equations with logarithms. So since this is an e, I'm going to take an ln on both sides. So ln of 2 equals ln of e to the 0.05t. And then remember that an ln and an e cancel each other out. So this is really ln of 2 equals 0.05t. And then we can divide both sides by 0.05. And we can figure out what our t equals. So ln of 2 divided by 0.05, 13.863. And this time is always measured in years, so that's how many years it's going to take to double at that interest rate. And again, you can check your answer. If you take E and you take your 0.05 interest rate and multiply it by this amount of time, so multiply it by that previous answer, it comes out as 2. So it means it's going to multiply your principal by 2, so it's going to double your investment. It does work. Alright, part B. Part B is saying, okay, well this time we want to triple it. So instead of 2p, what are we going to have? We're going to have 3p. So 3p equals pe to the 0.05t. Divide both sides by p. 3 equals e to the 0.05t. Because again, the p's will cancel out. That one will cancel there, that one will cancel there. To get rid of your e, we're going to need to use an ln on both sides. So ln of 3 equals ln of e to the 0.05t. The ln and the e cancel each other out. So ln of 3 equals 0.05t. Divide both sides by 0.05. So ln of 3 divided by 0.05 is 21.972. And again, time in these problems is measured in years. So that's how many years it will take for the value to triple. And again, you can check it. If you plug that into your E, okay, you have an E, your interest rate is 0.05, and then you multiply it by that many years, that answer, you'll see that E comes out as a 3. So that 3 gets multiplied by your principal, which triples your principal. Okay. So that's how these financial problems work. You're just going to be using those handful of formulas, plugging stuff in, and then just doing a little bit of algebra to solve. As always, if you have any questions or any of the homework or anything, please feel free to send me an email.